at, and it goes this way, and it does it in a greedy manner. If you told it to not be greedy, it would give you these 3 characters. But we're telling it to go greedy, so it goes all the way to here and stops at this blank, and then stops at this blank. And so that's a nice little thing. Find the @ signs, go to the first blank, and pull that stuff out. And so that, with one little match, you've pulled this thing out. Now, of course, we've done that before with other techniques. So that's just another way to pull stuff out. Now, if we get this whole thing, but what if that's not exactly what we wanted? We can tell, we can give it a matching string that's different than the extracting string by adding parentheses. And so here's another example where we basically say, this is our string. We want to match from at the beginning, followed by a space, followed by, ignore the parentheses for the minute, 1 or more non-blank characters, followed by an @ sign, followed by 1 or more non-blank characters. So this is also going to, if there's no from, it's not going to be looking for that, right? So it demands the from is here, so it matches that, and the space is demanded as well. And then it says, oh, non-blank characters, great. I got an @ sign, great. Non-blank characters, oops, stop there. And so this is what's going to match. Now the key is that we don't actually want that back in our extraction. What we really want back in our extraction is this part right here. So what we do is we put parentheses in. Parentheses are code, they're code in the regular expression world. Parentheses say start your extraction and end your extraction. And so when you do this with a parenthesis, when you do it, without a parenthesis, you get the whole from, right? Without a parenthesis. Oh wait, no, okay, that doesn't have the from in it. So, but if you do that with the parenthesis, you match the from, but you only get this bit to come out as well. So you can add this to make the matching part more precise, but without changing what you get returned, and you specify what you want to get returned with the parentheses. So next I want to show you just a couple of different ways to use these newfound skills. So now what we want to do is use some of these newfound skills in some more practical applications of regular expressions. So let's go back to the way we first tore apart strings and look at the situation where if you recall, we just wanted the host name, right? This is an email address and we're interested in the host name. So we have this string and we go find the @ right? The find looks up and tells us the @ is at position 21. And then what we do is we say, okay, let's look beyond there to the space, and that tells us the space is in position 31. And then we're saying we can extract starting at beyond the @ sign up to but not including the space by saying @pos +1 : space position. And when we get that, now we have to have a thing that decides to only look at this on from lines, but then it can print out the host that is extracting of this information. So that was one way that we did that, right? One way we did it. The next way we did this was the double split pattern, right? So we said, okay, let's take this line, let's break it into words based on spaces. That's what words is. So that's 0, 1, 2, 3, 4, 5, 6. And then we know that the email address on lines that start with from, space, is the second one. So we pull out email address, which pulls this bit out into email. And then we're going to split that again based on the @ sign. So we're going to split this part again based on the @ sign. So it splits right there, and then this becomes the 0 and 1 in pieces. And then pieces sub 1 is that host. And if we print that out, we get the host. So that's the double split pattern. Nice thing about that is you don't have to keep track. The little +1 is kind of annoying to use the space position. That previous one, that's just hard to remember. It's just, I've written this code way too many times in my career, and I've made mistakes, and I have to debug it every single time, and I print all these numbers out. I'm like, did I get it right? Oh, I did it in Python, I did it in Java, I did it in C. Wait a sec, I did it differently. And so this is a lot cleaner. I mean, I can write this every time, and I know it's going to work every time. I barely even need to test this code because it's so obvious. So double split is another way of extracting stuff. But if we look at this thing with the regular expression, we can say, oh, okay, let's use a regular expression to do this. So we'll start looking through the string. We'll start by saying, hey, let's look until we find an @ sign. Then let's start extracting with the parentheses, and then once we have found the @ sign, let's look for non-blank characters. This is a set of characters. This caret as the first one means not a blank. So that's another way to do non-blank. Not a set of characters which are everything but blank. That's what this little bit is saying. Star means 0 more times, which means it's going to run until it finds a blank, which is going to stop it. The greediness is what keeps pushing it, right? This is a greedy match. That asterisk is greedy because there's no question mark after it. And so that does go and starts at the @ sign with the parenthesis, goes to the space, and that's the end parenthesis, and that's what prints out. Now, Y is going to be a list that's a one-item list that has the string in it that we're looking for, but you can just go sub-0 to get that guy right out of there. Okay, so that's sort of the regular expression version of it, but we can make this a more fine-tuned thing. So we can say, look, we also want to pick the line, and we want to know if we don't get that line, we want to skip it. If we do get the line, we want to extract the data, and we can do this all in a single regular expression. So again, we say start from the beginning of the line, and if it's got to be a from, followed by a space, and then followed by any number of characters, dot star, followed by an @ sign. So this has to match. We see a space, then we're going to have any number of characters, and then we're going to see an @ sign, and then we're going to start extracting, and then we're going to go non-blank, 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 up, blank, and extracting, and out that comes. And this has the advantage of the previous one in that makes it much more precise. If we look at the previous one, while it works on good lines, it might actually trigger on lines that we actually don't want to see. So this allows us to refine it so it only actually does this to lines that we care about. So it's sort of both an if statement and a splitting, extracting going on all at the same time by having a bigger string that we're matching than we're extracting. It's a way to kind of clean up your data. So here is a simple program that we're going to just put all this together and actually accomplish something. And so we're going to read through and look for lines in a file that have this form. And we're going to extract this number, and then we're going to compute the maximum of this. Okay, so we're going to extract this number and then convert it to a float and compute the maximum. So, we're going to open a file, we're going to write a for loop, we're going to strip. So we're going to do this for every line of the file, but the first thing we want to do is not get line. We want to discard all the lines except ones that have this. So our regular expression is look for lines that start with x-d spam-confidence : So that's a pretty strong match. If that's not there, we're not going to get anything. And then there's a space, and then start extracting, and then go as long, one or more digits and dots, that's a single character, and that's one or more, and then stop extracting. So that says start extracting, greedy, stop extracting. And so that's what we're going to get. Now, if the line doesn't have this, it means missing in some way, whether it's this prefix or this number. If the number's missing, it's going to fail too. We're going to get back a list, an empty list. So the first thing you have to do is check to see if you actually got a match. So you say if the number of items in the list, len of stuff, is not equal to 1, continue. And so this is the skip all the lines that don't match. Skip. So there could be thousands of lines that don't match. But then when this match hits, it's going to come down and fall through. Right? So that most of the lines will skip up, but then when we actually get one, and we know instantly that we've got one, and stuff sub-0, because that's what we extracted, is this number. And we can take the floating point of it, we append it to our list, we made a list to store them, that runs, the list grows, and then we just say what was the largest one. And so you can run this and see that. We have an escape character, and the whole idea is sometimes all these little special characters that make a lot of sense to us, we actually want to search for it. So what if we want to search for a $sign? Well, we just prefix it with the backslash. And that just means this is a real $sign. So \$ is a real $sign. So this says, I would like a $sign followed by one or more digits or dots. And so that's going to match a $sign followed by one or more digits. Dots are okay. This is a set, remember. 0-9 or dot That's a set of the list of legit characters. This is a range